The birth of our solar system, a cosmic journey. Chapter 1. A cloud of dust and gas. Long before the Earth, the Sun, or even the planets existed, our solar system was nothing more than a vast cloud of dust and gas floating in the depths of space. This cloud, known as a solar nebula, was a remnant of older stars that had lived out their lives and exploded in spectacular events called supernovae. These explosions scattered elements like hydrogen, helium, and heavier elements such as carbon, oxygen, and iron across the universe, creating the building blocks for new stars and planets. In this quiet and cold region of space, the solar nebula was undisturbed for millions of years. But one day, something extraordinary happened. Perhaps a nearby supernova explosion sent shockwaves through space, or maybe the nebula simply began to collapse under its own gravity. Whatever the cause, this once calm cloud started to shrink and spin faster and faster. As the solar nebula collapsed, its center became hotter and denser. Most of the material, mostly hydrogen, was pulled toward the center, forming a growing ball of gas. The spinning motion caused the rest of the cloud to flatten into a disk, with the dense core at the center. This was the very beginning of our solar system. Chapter 2. The birth of the Sun. As the core of the collapsing cloud grew denser and hotter, it eventually reached a critical point. When the temperature hit around 15 million degrees Celsius, or 27 million degrees Fahrenheit, nuclear fusion began. This process is what powers stars, including our Sun. In nuclear fusion, hydrogen atoms smash together to form helium, releasing enormous amounts of energy in the process. With the start of nuclear fusion, the core of the cloud ignited and a new star was born. This star was our Sun, a massive ball of burning gas that would soon become the heart of the solar system. The Sun's immense gravity kept the rest of the solar nebula in orbit, trapping it in a spinning disk around itself. The Sun continued to grow, consuming more and more of the hydrogen and other elements around it. As it did, the surrounding disk of gas and dust began to cool and condense. The stage was set for the formation of the planets. Chapter 3. The formation of the planets. Within the spinning disk of gas and dust surrounding the young Sun, tiny particles began to stick together. These particles collided and clumped, forming larger and larger bodies over time. These growing clumps are called planetesimals, and they were the seeds of the future planets. Closer to the Sun, where temperatures were extremely high, only materials with high melting points, like metals and rocks, could condense. This led to the formation of small, rocky planetesimals. Further out, in the colder regions of the disk, ices and gases could also condense, allowing planetesimals in these areas to grow much larger. Over millions of years, these planetesimals collided and merged, growing into even larger bodies called protoplanets. The gravity of these protoplanets became strong enough to pull in more material, helping them grow even bigger. Eventually, they became the planets we know today. The inner solar system, closer to the Sun, saw the formation of the terrestrial planets: Mercury, Venus, Earth, and Mars. These planets are small and rocky with solid surfaces. Further out in the colder regions of the solar system, the gas giants formed: Jupiter and Saturn, followed by the ice giants, Uranus and Neptune. These planets grew massive by collecting not only rock and metal, but also large amounts of gas and ice. Chapter 4. The early solar system. While the planets were forming, the early solar system was a chaotic place. Planetesimals and protoplanets were still colliding with each other, sometimes merging to form larger bodies and other times shattering into pieces. Some of these collisions were incredibly violent, leading to the creation of moons, rings, and even tilting planets on their axes. One of the most significant events in the early solar system was the formation of the Earth's moon. According to a widely accepted theory, a Mars-sized protoplanet called Theia collided with the early Earth. The impact was so intense that it ejected a huge amount of debris into orbit around the Earth. Over time, this debris came together to form the Moon. The young Earth was also undergoing significant changes. As the planet grew, its interior heated up due to the energy from collisions and the decay of radioactive elements. This heat caused the Earth's materials to separate, with heavier elements like iron sinking to form the core and lighter materials rising to form the crust. During this period, Earth was bombarded by leftover planetesimals and comets, a phase known as the Late Heavy Bombardment. This constant raining of space debris brought not only destruction but also water and organic molecules to Earth, which would later play a crucial role in the development of life. Meanwhile, in the outer solar system, Jupiter's massive gravity was shaping the orbits of other planets and smaller objects. Jupiter's influence helped to clear out much of the debris in the outer solar system, either by flinging it into the sun, ejecting it into deep space, or causing it to collide with other bodies. This process also led to the formation of the asteroid belt, a region between Mars and Jupiter filled with leftover rocky material that never formed into a planet. Chapter 5. The birth of the moons and rings. As the planets settled into their orbits, many of them began to capture smaller bodies with their gravity. These captured objects became moons. Some moons formed alongside their planets from the same disk of gas and dust, while others were captured asteroids or planetesimals. Jupiter, the largest planet in our solar system, ended up with dozens of moons, including the 4 largest ones: Io, Europa, Ganymede, and Callisto. These moons are fascinating worlds in their own right, with active volcanoes, subsurface oceans, and icy surfaces. Saturn, another giant planet, also gathered a collection of moons, including the famous Titan, which is larger than the planet Mercury and has a thick atmosphere. Saturn is also known for its stunning ring system, made up of countless small particles of ice and rock. These rings likely formed from the remnants of a shattered moon or from material that never coalesced into a moon in the first place. Uranus and Neptune, the ice giants, have their own systems of moons and rings, though they are less prominent than those of Saturn. Uranus is unique in that it rotates on its side, likely due to a massive collision early in its history, which also gave it a complex system of rings and moons. Chapter 6. The Kuiper Belt and Beyond. Beyond the orbit of Neptune lies a vast region of space known as the Kuiper Belt. This area is filled with small icy bodies, including dwarf planets like Pluto and Eris. The Kuiper Belt is a remnant of the early solar system, containing material that never formed into full-fledged planets. These distant objects, called Kuiper Belt objects, KBOs, are similar to the building blocks of the outer planets. They offer a glimpse into the solar system's early history, as they have remained relatively unchanged for billions of years. Even further out in the distant reaches of the solar system lies the Oort cloud. This spherical shell of icy bodies surrounds the solar system and is thought to be the source of long-period comets. These comets take thousands of years to complete a single orbit around the Sun, and they represent the outermost edge of the Sun's gravitational influence. Chapter 7. The Emergence of Life. While the solar system was taking shape, Earth was transforming into a unique world capable of supporting life. The bombardment of comets and asteroids during the late heavy bombardment brought water and organic molecules to Earth, creating the conditions necessary for life to emerge. As the Earth cooled, water vapor in the atmosphere condensed to form oceans, and the first simple life forms began to appear. These early organisms were single-celled bacteria, but over billions of years, they evolved into more complex life forms, eventually leading to the rich diversity of life we see today. The Earth's position in the solar system played a crucial role in the development of life. Located in the habitable zone, or the Goldilocks zone, Earth is at just the right distance from the Sun. This allows for liquid water to exist on its surface, a key ingredient for life as we know it. The Moon also played a significant role in stabilizing the Earth's rotation, preventing extreme climate changes that could have hindered the development of life. The interaction between the Earth's gravity and the Moon's gravity also gave rise to the tides, which may have helped life transition from the oceans to land. Chapter 8. The Solar System, Today and Its Future. Today, our solar system is a well-ordered collection of planets, moons, asteroids, comets, and dwarf planets, all orbiting the Sun. But it hasn't always been this way, and it won't remain this way forever. The Sun, now about 4.6 billion years old, is a middle-aged star. It has enough fuel to continue shining for another 5 billion years. However, it won't last forever. As the Sun ages, it will eventually run out of hydrogen to burn and will begin fusing helium, causing it to expand into a red giant. When this happens, the inner planets, including Earth, may be engulfed by the Sun's expanding outer layers. Eventually, the Sun will shed its outer layers, leaving behind a small, dense core called a white dwarf. This white dwarf will slowly cool over billions of years, fading away as the solar system drifts into the future. Long before this happens, however, the planets and moons will continue their journeys around the Sun. New comets will continue to arrive from the Oort cloud, and the distant Kuiper belt will remain a quiet frontier on the edge of our solar system. Chapter 9. The Endless Journey. The story of our solar system is one of constant change and evolution. From a cloud of gas and dust to a vibrant collection of worlds, the solar system's journey is far from over. As we continue to explore the planets, moons, and distant objects within our solar system, we uncover new mysteries and deepen our understanding of how this incredible cosmic neighborhood came to be. And so, as we look up at the night sky, we're reminded that our solar system is just one small part of a vast and ever-changing universe. The same processes that formed our sun and planets are happening all over the cosmos, creating new stars, planets, and perhaps even life. The journey of our solar system is a testament to the power of the universe's forces. And as we continue to explore, we become part of that ongoing story, one that began billions of years ago and will continue for billions more.